even though it's a very difficult concept to use in practice and it trips up a lot of students, you're actually probably very familiar with limiting reagent problems, and you know them from the context of recipes or preparing some kind of a meal where you either have to scale up or scale down a particular recipe, or you have to figure out which ingredient is going to limit how much of a food product you can make. So let's consider a burger where you have a final product of a burger that has 2 buns, 1 bacon layer, 3 meats, and 3 cheeses. The ingredients for this are 2 buns, 1 bacon, 3 meats, and 3 cheeses. There's not really anything exciting about this. I didn't package these up into packages that you'd have to count up. And the question is, if you had a certain starting amount in your inventory of buns, bacons, meats, and cheeses, could you figure out how many of these hamburgers you would end up being able to make, these special burgers that have multiple layers of meat and cheese and buns, and also what would be left over of the ingredients when you're done? So what you would do is you'd create what I later call in the class as a ICE table. I standing for initial, C standing for change, and then E standing for ends with or equilibrium when you go into the next class in the series. But essentially, you're just tallying up the initial and getting rid of the change. You're subtracting away whatever got reacted or whatever got used up. So let's take a look at our example and work with that. So what you could do is you could say, well, okay, if I start with this inventory of 8 buns, 5 bacons, 10 meats, and 12 cheeses, you could ask yourself, what scale could you do this recipe on? If you had, just thinking about the buns, if you had 8 buns, that means you could actually, based on the buns, do this recipe on a scale of 4 times, right? Because if none of the other ingredients were an issue, you could do this 4 times over. Because each time you do it, it takes 2 buns. So the multiple of the recipe, or the scale of the recipe you're writing this on, is 4 times, potentially. For bacon, since you only have 5 bacons, you can actually run it 5 times because there's an implied 1 here for the number of bacons that it takes to build this particular burger. So you could actually run it 5 times for bacon. All I'm doing here is I am dividing the initial quantities, the initial counts, by the recipe stoichiometric coefficients. For meat, I could do it 3 times over because I have 10 initial meat patties, and each recipe requires, or each burger requires 3 of them. So what I'd be able to do is run this recipe 3 times, right? I can't run it a 4th time because that would require 12 meat patties, right? I only have 10, so I can only run it 3 times. And then finally for cheese, since it takes 3 cheeses to build a burger, I can do this recipe 4 times based on having 12 initial cheese slices to put into the burger. So 4, 8, 12, I can do 3 burgers based on, sorry, 4, it's multiples of 3, sorry. So it's 3, 6, 9, 12. I can do 4 different burgers using 3 slices of cheese each. So these are just the multiples that I could run each. I could run this burger production based on if I only was considering those ingredients by themselves. But now when I think about it, I look at all these different multiples that are possible, and I realize, well, the smallest scale that's allowable, the limiting scale here, is the scale that is presented to me by the meat. I only have enough meat to build 3 burgers. So that's the scale I'm going to be forced to use. And whatever's left over from the bacon, from the buns, from the cheese, those are going to be excess. But my limiting reagent here is meat, and I'll end up having not enough to do the reaction anymore with meat, or not enough to build this burger anymore with meat. So let's check this out. If the scale of this is 3 times the recipe, then I would end up making 3 times whatever the products are, and I'd end up using up 3 times whatever the reactants are in the balanced equation. So if I look at this, there's 2 buns listed, so I'm going to end up using up 6, so the change is subtracting 6 for this bun ingredient. For this bacon reactant, or this bacon ingredient, we have a multiple of 3 again. That's the limiting multiple of the scale that the production or the reaction is run on. So since there's only 1 bacon and I run it at a scale of 3 times over, it's going to end up just being 3 times 1 is 3. That's the amount of bacon that gets used up. I start off with 5. I end up with 2 because I subtract the 3 from the 5, and that's what I end up with when all the burgers are made that I can make. I calculate the number of meats that are going to be consumed by this reaction by multiplying the scale of the reaction, 3 times the 3 stoichiometric coefficient, and I end up getting 9. So I'm going to subtract that from the initial amount, and I end up getting 1. Same idea here with cheeses. The scale is 3. I have 3 in front of the cheese, so 3 times 3 is 9 cheeses that are consumed to run this recipe on a 3-fold scale. And since I started with 12 cheeses, I'm left over with 3. And finally, the number of burgers that I produce, I started with 0. I ended up making 3 times whatever the stoichiometric coefficient is. Since I ran the recipe on a 3-fold scale, 3 times that product, I get 3 of them. So 0 plus 3, I get 3 at the end. So if somebody asked me what would be left over once I'm done with my burger production, I'd be like, well, I'd make this chart up, and then I'd be like, okay, I'm going to end up with 2 buns, 2 bacon, 1 meat, 3 cheese, and I end up with 3 completed burgers. Now, what if they had some follow-up questions? They might ask me a question like, hey, Joe, why do you have 2 buns left over if your recipe says it only takes 2 buns to make the burger? And my answer would be, because I don't have enough meat, right? I don't have enough meat to do this. If you want some substandard burger, then we'd have to come up with another recipe, and you get 1 crappy patty. And the way things work in America is you need at least like 3 heart attacks worth of meat before you can sell this thing, all right? This is not worthy of Burger King.
So that's the complete state, or else just...
Yeah, I mean, it has to be completing this reaction. That's how you do it. If you had somebody asking you, if your manager asked you, well, you have these 3 cheese, why didn't you make another burger? Your answer would be, well, I can't because I don't have enough meat yet. We ran out of enough meat to do it. So that's how you would answer that kind of a question. Your limiting reagent here is meat. It's what you ran out of, and you didn't quite run out of it here, but you didn't have enough of it left over to actually complete the reaction. So that is my analogy for limiting reagent, and we'll do actual chemistry next, okay?